Okay, we've got some different ways of looking at the data now. We have to try and figure out what's going on. So what do we have? The mean difference we have is minus 0.12. So we can see that that says the mean difference. If I look at my histogram, it should be somewhere around here, just below there. But we can see the mode is actually somewhere above. So we've got something else going on here, and we've got something at each end. So from our P10, P90 plots, we see that we had larger uncertainty on the bottom end. That's reflective of this data down this end. So what that's telling us is that the model we're using is, on average, not too bad, because the mode and the mean are around about the right numbers. Let's get the standard deviation while we're here. That's relatively easy. So I'll just write this one as, that's a mean there. Standard deviation. Oops. In this case, the standard deviation, so just drop. Standard deviation equals standard div of those numbers above. So that's really easy to get. Thanks to Microsoft. And it's 0.06. And if you had a normal distribution, if the data is a normal distribution, which clearly it's not, you could work out of P10, P90, it's approximately 1.28 times the standard deviation if it's a normal distribution, which is not. The fact that we're getting 0.08 here, and we can see from our range, tells us this is, as we know it's not a normal distribution, there's something else going on. And in this kind of situation, it would normally tell me that we need to do something more interesting with our grain densities or our porosity to porosity interpretation. This is porosity interpretation we've used here is fairly basics, just a straightforward density porosity. There are some things we can do, as you'll see in the next stage, to try and optimize it a bit more. Okay, so we've got some statistics there. We can see what it's telling us, means, modes, standard deviations. Let's move on.